When it comes to raycasts in Unity, I remember when I was a beginner that there was a lot of confusion on what it is because watching 4 or 5 different YouTube videos, you would have 4 or 5 different implementations of it. This is because there's many ways to implement a raycast in Unity, but they're just different ways of writing it. So we must first understand what a raycast is and what its components are. I've already highlighted the word ray in green and cast in purple. Green is a specific color because collisions are green in Unity. I always imagine them green because their components are green. And then the cast is just purple because, yeah, I decided so. So the raycast is built out of these 2 components, and they're used to get information from the world. So think of it as a laser beam. Like I have a laser in my hands, so starting from this point, and I want to point towards this direction. I want to know if there's a wall in this direction, and if there is a wall, I want to get information from it, or I don't want to get information from it. All we care about is the base form of the raycast, and it's, are we colliding with something or are we not? So we have this origin point, and in the example of holding a laser beam, the origin point, we're going to call this A, and I'm pointing in a direction. Direction is given by what we call a vector. So a vector is nothing more than some 3D coordinates. So we have X, Y, no, that's a 7, Y, and Z as a vector 3. This can also be a vector 2, but vector 2 raycasts are a little different, but the principle is the same. So I will make another video on 2D raycasts. Right now we're focusing on 3D. So we have this origin point and we have this vector. So what you can think about is that we have 2 vector 3s. One is A, and another one is the direction. So we have the origin point and the direction. The direction basically means that if I have X on 1 as a value 1, I'm aiming towards the right. If I have X on the Y-axis, I'm aiming upwards. And Z-axis just means that I'm aiming forwards. I'm not sure what your background is because some applications have Y and Z inverted. Unity has Y as the up axis and Z is the depth. Now that we know that a ray is built out of an origin point and a direction, we can also say that a ray has a length. It can also not have a length if we want an infinite ray, but we can also define the length. So if I want to know if there's any objects within 4 units of distance from me, then that can happen as long as I pass the distance 4 to my ray. And this means that in this situation over here, in this scenario, there isn't any objects, so the wall won't be detected. On the other hand, if this was infinite, like not known, I will just get the point over here. I would be able to understand where I'm colliding, the exact point, and if there is any objects. And where we're casting a ray, it's basically like, if I hold a laser beam in my hands, I am not casting it until I push the button. So casting just means emit. I like casting a spell. In this case, I'm casting a ray. And that's about it for what a basic raycast is. With that being said, we can now go into Unity and I can show you some code. Okay, we're inside Unity, and this is a scene I've used to explain rigid bodies. This actually comes pretty in handy because I have plenty of cubes with box colliders, and they even have this little plane, and they have different colors, different sizes, and this is great for demonstrating what raycasts actually are. Let's create a script. Let's just call this script Raycast emitter. Here we are in the code. All we care about is having a ray, which is going to be our ray. We're going to call it ray. It's going to be what I said before, our element that has an origin point and the direction. So this is what we do, new ray. And inside the ray, we have two constructors. There's a default one with no parameters, which is a little useless. And then we have our vector3 origin and vector3 direction. So I want this ray to start from transform.position. So the position of the game object this script is attached to, and the direction I want to do transform.forward. And that's it. Just for a little bit of clarification, just to be a little clear, there's also a parameter that's called vector3.forward, but there's a little difference to this. This is a shorthand for writing 0, 0, 1, so 1 on the z-axis. Transform.forward, on the other hand, is a normalized vector that represents the blue axis of the transform in world space. What does that mean? Make sure you're in local orientation over here, and you click over here. You see there's this blue axis that is like, it's a little different compared to what this blue axis is. I can actually make this a little more exaggerated. So these are the global coordinates, right? I have x, y, and z, and here are the local coordinates of this cube. So this cube's blue axis is pointing in this direction. So this is the forward face of the cube. So our ray is going to start from here, and it's gonna follow the blue axis. That's what our script is going to do. And instead, vector3.forward points in this direction over here, because as you can see on the top right, z is facing this direction over here, because the blue axis is down there. Back to our code. So what we said is that our array is going to start from the position of the game object that's attached to, the script is attached to, and then we have the forward. And now we have to do a bool, and we're going to say hit object. It's going to be equal to physics.raycast. And as you can see, there are many overloads. If you do not know what an overload to a method is, I will have a video about that coming up shortly. So stay tuned, or either way, you can look up C# method overloads. Like this, you can understand much better what all of this is. So the overload that we're looking for the constructor, well, it's not a constructor, it's just a method overload. We're looking for, if IntelliSense will show me all the, there we go. We're looking for ray, just simply ray, and then eventually max distance. We're going to slowly add more parameters to this. So ray, and that's it. What I'm going to do now is if hit object is true, you could also shorthand this like this. There's no need to say equal true, like it's true. Like Ryder even grays it out for me, because this isn't Visual Studio. Ryder is a little bit smarter. He says it's not meant to be there. Like you could do it if you want to, but it's grayed out. It's not needed. So if we hit an object, what I want to do is debug.log. There is an object in front of game object.name. That's it. So I'm going to print the name of the game object that the script is attached to. And the game object we're going to use is going to be, let's see, what 3D models do we have? 3D objects, we can have a quad, a sphere, a cube, or a capsule, or a cylinder. Let's just make a sphere. I'm going to squish it a little bit like this. We know where it's pointing at. Yeah, it's like that. That's good. And then we're going to just throw our Raycast emitter over here, and we can drag it down, and we're going to hit play. Right now, nothing is going to print. Nothing's going to show up on screen. Let's go to our scene view. And what is going to happen is that when our z-axis is going to face these cubes, we're going to start getting that message. There you go. There is an object in front of sphere. So sphere is this object here. And we do not know what object is in front of it. All we know is that there is an object. And we don't even know how far away it is. So let's do another thing now. Let's go to our code and create a variable, public float ray distance. So this can tell us how far our object is. So we have our ray, and then we have a ray distance. Sorry, not in the if, it's in the Raycast over here. There you go. A thing to notice is that Raycast is part of physics, the physics class. This is because all collisions matter to physics and physics only. There's no point in having collisions if you don't have a physics engine, because physics engine is what makes collisions happen. And what we need is to detect a collision with a ray. So that's why it's in the physics class. Okay, so now we have ray distance set to 0. Let's put this guy to 3. And let's turn him around over there. Or actually, let's do 2. Let's press play. And I want to show you this. Nothing's appearing now. Remember how it used to appear? If I bring it close enough within 2 units of distance, there it is. There is an object in front of sphere. We still don't know what object it is and what its characteristics are. Okay. If you watched other YouTube videos, you might have also noticed that people don't write it like this that much. What you see is if physics.raycast, you have ray and ray distance, right? And that means that this boolean over here is not needed. It's just to be clear about the fact that what this method returns is a bool. So as you can see, public static boolean raycast. This is the declaration of this method. We have another way of writing physics.raycast. It's by not creating the ray beforehand. Physics.raycast allows us to directly define the ray's properties when calling the method. So what we can do is transform.position. So we put in initial vector 3, and we have transform.forward. As you can see, we have origin and direction. It's the same thing as writing ray, and then the next parameter can be ray distance. As you see over here, float max distance. There you go. Now, another topic that I often find complicated, like I used to find complicated, is layer masks, but that is because people usually explain it using bitwise operators, and it's not really needed. What is a layer mask in the first place? We can use layer masks with raycasts to filter objects. So let's say I want a raycast to ignore walls, and I just want to know if there's an enemy through that wall. Like this, I can hint for a quick trick shot, or I can do something really cool. We can do that as long as our layers are fairly organized. And to do that, we need to define a layer mask as a variable. So if we do public layer mask, that's all we need to do. And then over here, we can just feed the mask to our raycast. This line we can delete. And here we go. Basically, our mask is being transformed into an integer. This is because layer masks are binary, and they're in binary form, and you can store a binary number as an integer. Inside the inspector, our mask will now look like this. We have nothing, everything, default, transparent, ignore, raycast, water, and UI. Let's just run it like this. Nothing will happen. Nothing will show up. And as you can see over here, if I bring it close, nothing happens. But if I put everything, we will start getting some collisions. There you go. There is no object in front of sphere. As a proof of concept, to put to nothing, the number ain't going up. I can clear this and nothing happens. I'll put default and it will start happening. This is because these cubes are all on default. It's the default layer that gets assigned to them. But if by any chance I want an object to actually ignore raycast, what I can do is click on here and put ignore raycast. See, nothing's happening here anymore. So this cube is ignoring raycast, and if I move him more this way, this one is on the default layer, and that's when it works. You can also add layers by clicking over here and clicking add layer, and then this array shows up. You have a lot of user layers, and here you can type in whatever you want. So over here I can just call this terrain, and I can assign the ground now, layer terrain. It shows up right over here. So now in our sphere, on the mask, if I click terrain and clear on this, you can choose more than one layer. So you can get rid of that, and okay, we're not getting any more hits because these are no longer terrain. What is terrain is the ground. So if I aim him downwards, and this is more than 2 units, so I'm gonna put this to 5, for example. There you go. There's an object in front of sphere. And that sums up about most uses of Raycast, most constructors, but there's one very extremely important thing, because we typically don't care much if there's an object in front of us or not. We want to know what object is in front of us. We might be putting a raycast, we might be casting a ray to damage an enemy because we're shooting bullets. Or we might want to interact with an object that's on the ground. So we need to know if the object we're looking at has a tag interactable, or if it has a component interactable, and that allows us to interact with it. How do we do that? We've seen the ray variable, the ray type, and now what we need is the Raycast hit type. And this is usually called hit. You can actually name these however you want, but we're calling it hit. And we're going to declare it as a new Raycast hit. That's it. Now, instead of ray distance, before we have our distance, we can do out hit. Now, when we refer to this variable, we can access the properties of the Raycast. What does out mean when we're writing a method anyway? Because I remember I used to look at tutorials and would say out hit. I would just memorize these like a poem that I have to say in class at school. That is not the right thing to do. We need to understand what we're dealing with here. So you know how methods can return only one type? In this case, this guy is returning only a bool. So we need to know if we're interacting with an object, then proceed, then run whatever's in these brackets, run this piece of code. But we need to also return another parameter in this case, which is the hit info. And out basically means that whatever we put in this part, in this parameter of the method, will be modified, and we can reference its changes. In simple words, we're basically saying, hey, take this hit variable that I declared previously and write the information you find when you hit an object, when you collide with an object. That's it. And so when we do hit dot, we can access a lot of things. We can access the collider's properties, the distance. So if I have an infinite ray, or I want to see how far the object is from the origin, I can access the distance. I can even access the normal, which is something a little more complex, but it's the normal of the surface the ray hit. Yeah, this explanation isn't really that clear. It basically means the direction that surface is facing. It's just a specific surface. If it's not the forward of the object itself, it's the surface. So this allows us to make bullets bounce if we ever wanted to have something like that. Or we have a ball that we want to throw around, we can make it bounce by accessing the normal, or we can just let physics do that. We can do a lot of things. And then point is probably the most used thing if you want to leave bullet decals, because this tells you the impact point in world space where the ray hit the collider. Okay, this description I actually like. It's pretty self-explanatory. Rigid body, this is not guaranteed that it's that it has content. It might be null, because all you need for a Raycast to hit is a collider. There are certain scenarios that really don't come to my mind right now that you do need a rigid body, but typically you don't. Then we have the transform, and there's a lot of things over here. So what we want to do is access the transform. So we want to print how big these game objects are. Hit.transform.local scale dot magnitude. This basically means I want to see how many units cubed this cube is, like the size. So we can do that with debug dot log. We're gonna put the little dollar sign, and we're gonna be closing this over here. Okay, the dollar sign allows us to put square brackets and enclose variables inside our string. It's nothing different than doing string.concat as calling a function, or putting the plus sign and then the variable. It just comes in handy because we can now write things like the object the Raycast has hit is of size and is in let's say hit.transform.position. Now we can also test this out. Nothing stops us. So our mask is detecting nothing. We want to put it to default. These guys are all set to default. Okay, now we can proceed. Let's click on the play button. And where is this guy? Okay, he's over here. We have array distance of 2. Let's put this to 999. Okay. What we have over here is that we have an object that's in front of sphere. We know that he's 1.73 units big. Well, yeah, that's the scale. Yeah, that makes sense. Calculating the magnitudes, it makes sense. And then it's in 5.6, 0.6 minus 14.4 as position. 5.6, 0.6, or 0.6, or negative 14. Yeah, that sums it up. Unity also does this little approximation. Here it says minus 14.35, and he does an approximation when showing it to negative 14.4. But that seems pretty cool. We have all the information we need. And that sums it up. This is basically what Raycast is under most of its constructors. We can see all the constructors by holding Control and clicking on Raycast. I highly recommend doing this. Even if you're a beginner, don't be intimidated. You're going to see a lot of stuff. But in general, this is basically the same method as if you were writing a method in a class with all of its overloads. It's like looking at documentation without having to go onto the website. The only thing is that you don't have an explanation. But it's good to just see what you can do if your IDE is a little lazy and it doesn't show you all of the examples all at once. So we have the Raycast with origin, direction, and max distance. We have the Raycast with origin and direction only. I've shown that as well. Then we have origin, direction, max distance, and layer mask. And then we also have origin, direction, hit info, max distance, and layer mask. Then there's query trigger interaction, which is, I don't really know what this is. It's probably used internally within Unity. And yeah, it seems pretty much what it is. So we can't really know what that is. We would have to look at the docs. So yeah, that is actually everything about Raycasts. And thanks for watching. If you watched the video entirely, I deeply appreciate that. Let me know in the comments down below what you think, what can be improved, because I'm still learning as I'm going. And if you have any questions or something ain't clear, also let me know in the comments. I'll do my best to answer as soon as possible. If you've enjoyed the video, please leave a like, and if you haven't already, hit that subscribe button.